Here is a bigger diagram for this question. Now, the key thing is trying to work out what is actually tessellating here. Because if you try to take a hexagon and then all the triangles that surround it, that is not what is tessellating. Because as soon as you then look at the next one, well, it's got no triangles that are associated with it. So it's not going to be all six. So maybe a good starting point is to think, well, I'm just going to take this and maybe I just take one of them. So this one here. So then I'm going to get this and this, and I'm going to get this green one and this one, and then this purple one. Well, you can clearly see that I'm missing one here. And that gives a new idea then. So it's not just going to be one triangle associated, maybe it's two. And because that was the one that was missing, it seems a good idea to try and associate it with that one. Okay, there might be more than one way of doing this, but if I put this one up here, I think it's got to be this one that's next to it. So now when I do this blue one, it's going to be this one and this one. Let me do the green one down here. That's going to work. And I'm pretty convinced, I don't know about you, that this is always going to be possible now. Okay, so it's a hexagon. It's not, is it hexagon? A hexagon plus two triangles are tessellating. Okay, now we've got that, we can focus on the fraction of just this shape that is that's that's black. Now here's the key thing. We're gonna have to because it's we're told a large number of tiles is used to cover a floor. That's quite important because obviously at the end you can see we don't have these triangles associated, but we're basically assuming that this is an infinite pattern. In reality, if it's a large floor, it's going to be close to the fraction. Right, let's take a hexagon. So a key thing about a hexagon is that you can turn it into six equilateral triangles like this. Now, one of these black triangles is actually, you can see the length of it is half of this, which means we can split this up more into these smaller triangles. It's actually going to look like that. So each hexagon, um, there are 1, 2, 3, 4 times 6, 24 triangles of the same size as the black triangle in them. So 24 plus 2 triangles are contained by this shape, this hexagon and the two triangles. So the fraction that is black, well, two of them are black. There are 26 in total, so it's 2 over 26, which we can cancel down to 1 over 13. And that's the answer to this question. So step one was to work out what is actually tessellating. Step two was to somehow compare the area. And it is, it is vital to understand that, yeah, you can split this up. You could then use the idea of similar shapes instead. You could say, right, well, I've got this bit here. This is an equilateral triangle, and this one is the twice the length, so it's 4 times the area. So there must be 4 of these, and from that again, you can get the 24, and then add the 2 on to get 26, and then do 2 over 26. So that's an alternative way of thinking about it. If you didn't see to divide it up like this, it's it's equivalent. Okay, well done.